Hi, it's Nicholas Thompson. I'm the CEO of The Atlantic. And this is The Most Interesting Thing in AI, a podcast produced by Rethink, The Atlantic's creative marketing studio, in collaboration with PwC, a leader in helping organizations use AI. In each episode, we're exploring how artificial intelligence is reshaping our lives. We're back for another season of the show, and I'm thrilled to share our first episode with you. It's building off of something we talked a fair bit about last season, a sort of rift in the AI community over what makes a better, smarter AI. Most of us are familiar with the systems largely considered the winner of that debate, generative AI. That's the thing that fuels ChatGPT, Claude, Gemini, others. Generative AI models use something called neural networks to study masses of data, look for patterns in that data, and then generate answers to your questions based on that analysis. They improve, and this is important, through what is called scaling, meaning they're given more data, faster processors, more time. Somehow, adding more stuff into the mix just makes everything work. But there's another theory, and it's less popular and has a lot less money behind it. But it says, no, the way to go is through symbolic AI. You don't need masses of data. You instead need to give the AI a set of rules and help it gain logic. That's the way to smarter AI. So we have generative AI powered by scaling laws on one side, symbolic AI on the other side. But what if you combined the two ideas? What happens then? Last season, we spoke with the cognitive scientist Gary Marcus. He's long argued for this. He calls it Neuro-Symbolic AI. And the idea may be catching on a bit. Last year, Google partnered with a company called AUI, which is touting an agentic language model called Apollo 1. AUI says Apollo 1 will combine the fluency of a large language model with symbolic reasoning. Basically, it's neuro-symbolic AI. Theoretically, the model will produce more predictable, more accurate results than pure neural systems can do. As of this recording, AUI is scheduled to release the final results of its model very soon. And so for today's episode, I sit down with AUI's co-founder and CEO, Ohad Elhelo. I wanted to know what persuaded him that neuro-symbolic AI is the way to go, and does he actually think Apollo 1 will succeed? Here's my conversation with Ohad Elhelo. Ohad, thanks for being here.
Well, I've been looking forward to that.
No, this is going to be really fun and very interesting. So for decades, AI has kind of been split, right? There's been the symbolic AI approach, which is we'll come with a bunch of rules, we'll put them into the system. That's how we'll build AI. And then there's the neural network approach, which is we will take a bunch of data, we'll dump it into this giant cauldron, we'll stir it around, and we'll get intelligence. Mm-hmm. And the latter approach has been what's winning recently. Mm-hmm. ChatGPT, everything else. You feel that things are about to go in another direction. Explain why.
I think that first we have to understand that conversational AI is essentially split between two halves. And the first one is open-ended dialogue. This is where a chatbot like ChatGPT is essentially operating on a free-form user prompt and trying to generate the best outcome for what the user is looking for. This approach rewards variance, creativity. I think it has disrupted multiple fields already, like education. I think it has a unique set of use cases. But this is the first half of conversational AI. The second half is task-oriented dialogue.
Ohad, can you just briefly explain what task-oriented dialogue is?
These are the use cases of conversational AI that aren't open-ended. The agent have a specific task that it needs to carry on behalf of an entity. The conversation is centered around a specific action that drives the conversation towards completion. And it has three measurable properties that you could look at: how well it converses, how well it executes the tasks, and how well it adheres to policies.
But you can use a chatbot like ChatGPT to deal with tasks. You can say, answer this question, or you can say, do this thing. And in fact, there are agents that go off and do it. So it's not like task-oriented conversations are impossible with neural networks.
They're not impossible. They're just not consistent and reliable enough for any substantial deployment. And if you think about all the chatbots in the world, the open-ended chatbots will come to mind, Gemini, ChatGPT, Copilot, but you don't see Uber having a conversational AI on their behalf, even though for Uber Eats, it would be a banger use case, right? Same thing with Airbnb. You get something when you're trying to take the transformer architecture into task-oriented dialogue, but you don't get enough.
So the argument is, right now when I call an Uber, I still just say, I want an Uber, I want to go to this place. I do it all by my hand. I don't have an agent go and do it. Uber hasn't built an AI.
Mm-hmm.
I would imagine at the leading large language model companies, they say, well, it's just a matter of time. In a couple of years, or in a couple months, you will be able to use our bot, our system to call and summon an Uber and do everything in it that you need to do. You're saying that actually, it's not a couple months, it's not a couple years, it's never.
I mean, think about it this way. Today, when you're trying to book a flight with ChatGPT, it takes you to this browser agent, and that takes a couple of minutes per turn, per message. So ideally, if there was a good way to take a transformer and to make it excellent at task-oriented dialogue, in the past 3 years, we would have seen some serious deployments. But for functional task-oriented dialogue, you need fluent conversation. So you want to be able to communicate in natural language and expect the fluency of large language models. Then you have to execute either deterministically or at the very least reliably. And here you can think about that Uber Eats example. Let's say you converse with Uber and they say, okay, Nick, your order is $95. How many times out of 10 they want this interaction to go well? I would say 10 out of 10, because it's an awful interaction to miss.
Right.
And then the third thing that you need in task-oriented dialogue is you need a built-in mechanism to follow policy, because it is almost always on behalf of an entity, and this entity wants to have more granular instructions to the model in specific scenarios. So if you think about a transformer that has a system prompt where you give all the instructions to the LLM, so basically they're stateless. They're not based on a scenario that you're going to pin down and only show that specific set of rules. You want to be able to adhere to policies at a much more granular level.
And so with a regular large language model, the ones we're all familiar with, there's, of course, the fluent dialogue. So there's step one, problem solved. It's great. Step two, the reliability, absolutely not solved. We all know the hallucination problem. And in fact, if you have a multi-step process, and even if you have a very high odds of getting it correct, if there's some chance of getting it wrong, multiplied over multiple steps, there's a huge risk of getting it wrong. And then being able to verify that it followed the rules correctly, that is also a problem. So traditional large language models are going to fail on step 2 and 3. Okay, fair. So now you claim that you've built a system that can solve problems 2 and 3. So how did you do it and how does it work?
Okay. Around 2018, before large language models were around, but the deep learning paradigm was already very dominant, we have been very interested in understanding how human agents are solving all sort of procedural tasks. Booking a flight, finding people reservations.
Human agents meaning humans?
Humans,
okay.
Yeah. Today we have to clarify.
Yeah.
And we essentially had this theory that all those task-oriented dialogue use cases share the same primitives. So even if I'm right now acting on behalf of an insurance company and I have to collect the information to process a loan application, or if I'm a salesman working on behalf of Honda, the same procedural roles in those conversations, the same primitives, executing, searching, validating, clarifying intent, they all essentially live in the same domain. It is what you would call procedural knowledge, the know-how of how to accomplish a certain task. It doesn't extrapolate to all the tasks in the world. It extrapolates exactly within task-oriented dialogue. So looking at those millions of tasks that we have solved.
Wait, sorry to cut you off here because there's a lot to get through. But the theory is that if you look at the way Delta Airlines handles ticket requests, you can also figure out something about the way Honda processes muffler repairs?
In a task-oriented conversation, yes, it's not the same way, but you have to essentially develop what is called a symbolic language. You have to capture both the structure of the task. A task is comprised of multiple turns, multiple messages back and forth, and in each one of them, you would see similar patterns. You have to extract some information from the user. You have to go and exercise a certain tool and take the results and validate them against policy and so forth. So it wasn't our breakthrough, but our hypothesis that the same primitives essentially are shared across a very large majority of different use cases across domains.
Right. Across purchasing and task domains, you're not able to use these primitives or these conversations so that you can create an AI that will teach me how to play flamenco guitar.
Yeah, and we'll get to it after. I mean, I'm a firm believer in the animal kingdom vision of AI, where you'll have multiple or many, many species with general intelligence. I don't think that we found the one that's going to rule them all. And I think that they'll have different roles. And we're talking about a system that can generalize, therefore has some degree of general intelligence, but is by no means AGI and is not going to replace product managers, because those task-oriented dialogue use cases, essentially they run through, I would say, the commercial aspect of conversational AI in the economy. It's the returns, the processes, it's the applications, it's the patient intake form in the pharmacy or in the ER. It could evolve to things like 911. This is also a task-oriented dialogue, but it does not work for code because the symbolic language does not have the symbols to represent code in the same way.
Wow. Okay. So you have this insight or this hypothesis in 2018. You believe that if you study some giant corpus of task interactions, you will be able to understand some underlying laws of how tasks work, and you'll be able to build a rule-based architecture around it. But how do you start with creating the language? Like, what is the first word that you created in this new symbolic language?
Many times, the first step in a conversation would be to classify the intent of the user. And you have multiple use cases. They may want to cancel an account. They may want to upgrade their flight. Okay, so you are essentially classifying their intent. That's a very important part. But if you want to build a query to a flight search engine, you're going to need to extract those parameters. And we have just realized that you have to do it in a structured way. So you have to really be able to single them out, to isolate them, and to be able to hold them as entities that are serving you in your reasoning process.
Okay. So you build the symbolic language. You have 60,000 people. You've gotten the money to pay these people. How?
We raised money from people that had what you would call patient capital.
Okay. So you raised
a little below $50 million.
You then study all these interactions. You build your new language. Large language models improve. And then eventually what you've done is you've built some kind of system in the middle and you bolt it to a large language model?
No. So now if we want to talk about the emergence of large language models, for us, they represented a different source of a solution. So the majority of companies are using large language models as the cognitive core that is generalizing in a conversation. The large language model is the essential brain that decides what to do. This is the first architecture that has been able to do it in a way that people find useful.
Yeah.
But for us, they have solved specific problems that could have given us a vision to build a neuro-symbolic model. A neuro-symbolic model is able to enjoy the benefits of both approaches. Because as you said at the beginning, the symbolic approach was giving you reliability, was giving you controllability. But it was not giving you fluency. It was very brittle. Now, the large language models, they give you the fluency, but they don't give you the reliability and the ability to have consistency in the way that you respond. If you're a bank, you don't want a lot of variance in how you respond to those messages. If you're ChatGPT, you want this variance. You want to be creative sometimes. You want to think out of the box. So when large language models arrived, we have started the long journey to build the neuro-symbolic foundation model for task-oriented dialogue, to build a model that has a different architecture, a different cognitive core that will be able to have gains in task-oriented dialogue agnostic of the use case and the domain. And that was our R&D goal since the emergence of LLMs, because they've solved some critical problems for us.
So give me a specific example of how someone would use your system and what would happen.
Well, there is some way that people are using it now. It's not in general availability, but there are Fortune 500 companies with it in production. So let's say that you are at the automotive industry, and you're basically saying, I'm selling 5 cars a day on my website. I'm a big company, but I'm interested in selling warranties because this is where I have better margins.
Yeah.
So you have a team, essentially, that greets visitors to your website, and they would try to understand what's the intent of the user, right? And they'll try to understand, they'll do all those steps that we've seen the humans do when we're working with the human agents. And they would deploy our foundation model with a specific set of tools and settings that they've defined for themselves. And their use case would be, we want to both complete the loan application, if there is one, and to be able to complete the sale of a car. And the dialogue will be focused on what are the steps that the agent wants to make based on the goal that was dictated to it in order to drive the conversation to those outcomes. And we would need to do it consistently. So for that use case, you really want the fluency of LLMs, but you want the symbolic reliability.
All right, so let's go through this more because this is important. To me, the advantage of symbolic architectures has always been the clarity of having a rule, right? If person requests test drive and meets these criteria, say yes and schedule it first available appointment. And so you've got to do a couple of hard things. You're using an LLM to understand the user request, and then you're feeding it back into your engine, right?
You're encoding the user message into the symbolic language using neural models alone. And they would be doing NLU tasks, natural language understanding.
Yeah.
They're very good at that. And they can also do it agnostically of the domain, because for them to, let's say, extract parameters about a flight is no different than extract parameters about a patient. They just need to know the format or the right template for those parameters. So once the encoding has taken place, then this is going to be a little bit more technical. You have to capture a state, meaning that you have to capture the current scenario of this interaction in the conversation, and also specifically the current scenario in an ongoing loop where tool use is bringing back tool responses.
Right.
So you have to capture a state. Neural models assist in that as well. I believe that they have the ability to enrich the symbolic state given their ability to use flexibility. This is where some of the brittleness is going away.
The hard thing for me to understand here is it seems like there's a lot of back and forth and a lot of thinking that's going on. And the way I had always understood the advantage of Neuro-Symbolic AI is that once you kick it to the Neuro-Symbolic system, there isn't that much thinking. And there's a trade-off, right? Because if you have a bunch of rules, as you said, they're brittle and it's hard to make enough infinite rules to cover the entire universe, but they're rock solid. And once you're thinking, then I feel like you're in a world of fallibility and hallucinations. And so tell me how you're able to make sure that each step in this process and each step in this loop, you're not introducing errors, you're not introducing hallucinations, you're not introducing mistakes.
Because the symbolic language is shared by all of those components. So instead of computing over natural English or natural language, we are predicting the next action based on all of those same symbols that we know are anchored to specific situations.
So this is helping to clarify for me. Okay, so I run Nick's Cars, I sell cars online, I want to set up test drives. I make a deal with you. You say, okay, here's our software, here's Apollo 1. What I then do is I upload my policies on test drives. I upload my sales prices. I presumably build some kind of tool so that when I change the prices, it automatically uploads into the system.
Mm-hmm.
I then have uploaded all of those rules into Apollo 1.
Mm-hmm.
And then what you do is you take your symbolic language and you figure out when the customer request comes in, exactly how to respond to it based on all those files I've uploaded.
Exactly. You would already upload them into their symbolic slots. The idea here is that if I'm as the operator, as Nick's car agent manager, have uploaded all of those different tools and I have put my instructions, I can decide how granular I'm going to go. How specific can you be? Can I say that only on Honda Accord from 96 to 99, I want to give 2% discount? We enable you to do that because we have the parameter, the symbol that says you can name a specific item or product line, and you can attach a certain rule to it that says if this comes up and the user is saying, I'm looking to schedule a test drive, always remember to say to them that there is a 2%. In an LLM system prompt, you can also put it down in one of those do not forget, but this would not be stateful.
Right.
Because LLMs are stateless.
And then in order for me to have trust in your system, I also need to trust that you've encoded it properly. So a user comes in and they say, I have an old clanker, or whatever language they use, your system has to know that that means an old car, right? Or whatever the British slang is. You have to be able to map all of that out correctly. Because if you put in an incorrect input, even into a perfectly logical system, you'll get an incorrect output.
Yeah, the model is essentially probabilistic because the neural modules that are coming already at the beginning and encode, they can make mistakes, right? They're just going to make far less mistakes than you would see with the other approach. Let's also remember that part of my thesis and what we're going to introduce is a whole new generation of task-oriented dialogue agents because they already outperform what you can do with LLMs by a very large margin. Our goal was to make that scalable so that you could do that yourself and we don't have to essentially go and sit with you and build Nick's car's agent with you and be responsible for how it performs.
Okay, so I very much look forward to opening Nick's cars and seeing how well it performs. But when we come back, I ask Ohad about how exactly his software, Apollo 1, takes advantage of Neuro-Symbolic AI and what evidence he has to prove it. Does it actually work? Stay with us. We're back with the most interesting thing in AI. I'm Nick Thompson, CEO of The Atlantic, here with Ohad Elhelo, talking about his startup, AUI, which he co-founded with his partner, Ori Cohen. Ohad and Ori are soon scheduled to release the final public results of their agentic language model called Apollo 1 to the public. Ohad, tell me why you believe this is going to change everything. Have you run tests? Are there publicly available benchmarks? Just sort of walk me through that.
Well, when we come up with, when we release general availability, we will release results on one of the most important agentic benchmarks called TauBench. Mm-hmm. It's an interesting benchmark because it essentially has 50 conversations, complicated, with an airline, really representing users coming up with all sort of different requests and complicated requests. But it's a smart benchmark because, one, you can tell that not being able to do very well on those conversations really prohibits the airline from putting it up. And two, they're trying to measure it over pass 1, pass 2, pass 3, pass 4, meaning that they want to see the variance when you're doing it again and again. And on pass 1, the best result in the world today is 60%, and we're going to release 91%. So over a 50% increase. On pass 4, I'm still not sure to tell you what the numbers would be, but I expect the increase to be bigger. That's one benchmark that we're going to release. But one of the things we've done, and I cannot talk about them very publicly, we've run evaluations with some of those major agents that have been deployed. And there are very few of them because, as I said at the beginning, they normally don't work well enough.
Right.
Booking.com built an agent with OpenAI because flight search, for example, is a not simple tool use case. You have to build a certain query. You have to run all sort of fallbacks. You have to have confidence in this is really the best flights. So on some examples like this, we've shown between 4 to 500% increase than the leading agents. And this is already available in some environment that we're using for our own purposes. But when the model launches, these demo environments will be up there as well.
How much is the model going to be very good at a small number of tasks? And how much of it is it going to be, very good at a huge number of tasks? Like if you optimized it for flight booking and car sales and ordering pizza, like how far does it go? How far will it extend?
It goes to the extent of task-oriented dialogue. And
all task-oriented dialogue.
Yes. Every use case where an action drives a conversation. I'm basically saying that generative AI was the first wave. And we saw how most of its use cases are B2C, right? So if you think about the biggest companies in the world, they don't have conversational AI deployed at scale. I believe that the Neuro-Symbolic approach that we have is really unlocking that, and that the model is completely agnostic to the use case because we have not made any sort of optimizations for flights or for, retail, but rather we have mapped the field of task-oriented dialogue to all the scenarios and use cases that you can find there. And if you think about what they essentially run around the commercial use cases of returns, purchases, customer service, scheduling, and booking. And in the world of those open-ended dialogue chatbots, there are some things that they cannot do well or at all because these are task-oriented dialogue use cases. For example, Gemini would have loved to run a Super Bowl ad that instead of saying, build your next presentation with Gemini, shows an example of someone on their way to the airport and, their daughter is just giving birth and they have to be there. And they're saying to Gemini, put me on the next flight that leaves for Los Angeles tonight.
So what is your view? So in 2 years, I will use the same large language models I use now to understand the news, to learn about tasks, to help my kids understand their homework. But I'll be using symbolic architectures every time I want to do neuro-symbolic architectures, every time I want to do a specific business task.
There will be a use case. Yeah. I'm not shy to say that at least my expectation and my understanding is that the second half of conversational AI, task-oriented dialogue, is the bigger half commercially and economically.
So I'm just going to pause here and say to the listeners, I have no idea if this will work, but let's assume that it does work. All right. So let's assume that this magic box that you've built, right, and this way of understanding the linkages between all task-oriented requests not only works and not only expands as broadly as you say it will. You're then saying that your system will be bigger than OpenAI's because it will be more than half of conversations?
I'm saying that to the extent others have been trying to solve task-oriented dialogue, they have walked in a different direction. I would say that they have walked right and we have walked left. And I think that we found that the answer was 100,000 miles left. So it really required developing that symbolic language. And then it required the most complicated thing we've been working on is how to design a foundation model that can be as scalable as an LLM. So that if you're a shop in Indonesia, or you're a little vitamin shop in Spain, or you are a small insurer in Berlin, you could just go on and set your agent.
Yeah.
But I don't say that it will extrapolate beyond those use cases, because I believe that also the conversation about language models and AI is parochial in how short-sighted it is, and that there are some easy arguments to be made that we're not going to see an extrapolation of one architecture that essentially just takes more and more, not just because the evidence doesn't back it up. And we will, of course, have to show proof to what we've been saying here. I think that I'm looking forward to the reactions to that. But if you think about the future, and you run it 10 years forward or 100 years forward, do you really think that we're going to look at a scale transformer? I mean, if a transformer is a form of computation, did we at 2018 unlock the secret AI code of the universe that essentially is the sauce for AI, and now we're just scaling it forward? Or maybe in 10,000 years, AI will be based on physics that we don't even understand right now, and we'll have many different approaches. I think that it will have many different species. And I believe we've developed a cognitive core that is designed for task-oriented dialogue. And I think that transformers are designed for language purposes and open-ended dialogue.
All right, so let's talk about what the next 2 to 3 months look like for Ohad, because you're going to launch your product. And if it does work, and suddenly you've built the best system for buying things, and you've solved this agent problem, you're going to go from having very few users to having hundreds of millions to billions of users. So tell me how that feels.
I agree that the economic implications are very, very profound. And I'm far more interested in, the scientific and technical reaction to this architecture. I just want to find out if I was right and if this was the right design, and if people will eventually vote for this by using this. And I like my chances.
How will you know?
Well, you'll know very fast. I mean, this is it's the kind of a release that you will be able to see the full set of properties right away. So if essentially the reaction is this really changes what AI means for enterprises, what conversational AI is going to look like, then I would say it matches some of my expectations.
Right. But if on the first day, a pregnant mom is trying to get to Los Angeles, uses your system, and gets sent to Saskatchewan, then we have a problem.
Yeah, well, this is why our responsibility as founders was to make it work well. And I think this is what mattered to us. And I'm not trying to hype what Neuro-Symbolic is. I'm trying to say, I think this is exactly how it should look like. And this is a far better design. Many times I wondered how life took us in this direction, where this is the task we've taken on ourselves. But I think I told you also when we met before, I'm a real believer in trying to find out for yourself what you think about a certain topic. And the people that had to be convinced the hardest are Ori and myself, that this is the right approach, that this is working. And really, for a very long time, it didn't work because the idea was that you have to make it a foundation model that can work for every use case. I think it works, Nick.
So what do you think in 5 years? What do you hope Apollo 1 will be doing?
I hope it will be Apollo 5 or 6 by then, or 10.
Yeah, you hope Apollo 1 will be mothballed. Yeah. But what do you hope about Apollo 5?
I would like to see task-oriented dialogue working in real-time video modality. I think a lot of already now, the deployments that I would like to see the most when we launch are also running on different messaging channels. I think a lot of the conversations with businesses can be on WhatsApp or messaging or voice messages. I'd like to see them happening in real time. I would like to see the use cases evolve to be ever more granular and specific. And I would like to see how this form of AI for task-oriented dialogue shows its own emergent properties. Because I think that while I don't see it ever becoming the AI that, replaces the product designer, I think that we would be able to represent symbolically also larger set of use cases that are beyond task-oriented dialogue as we understand it right now. And the task-oriented dialogue will evolve beyond what it is today.
That's interesting. So your AI definitely won't kill us all, right? We don't have to worry about that.
You're safe.
Thank you very much. But you do think it could end up doing things that you haven't imagined yet. And you, in fact, hope that that happens.
I'm sure that it will happen to a degree. I think that I mentioned before the animal kingdom of AI.
Yeah.
As what I believe we're going to see. I think we're going to have many different species. And I think that the species we've developed, the cognitive core we've developed, is very suitable for those procedural tasks. It can excel at them, and it can also scale beyond what they are today.
Last question. What's the most interesting way you've used AI recently?
Many times I was sampling the views of chatbots on our thesis. I would basically put it in those no memory functions, so it will not try to please me. And I'll basically say sort of stuff like, this just landed in my inbox. What do you think about it? And I would see and observe how different chatbots react to the thesis.
Oh, really? What do they say?
Well, the general theme is very positive because they say, well, we surely agree that transformers are not ideal for task-oriented dialogue, but there would be a variety of different responses. I did find that an interesting new experience for me. To wonder what a chatbot thinks about what I dedicated the last 10 years of my life to was not something that I expected to do personally.
That's a great answer. All right. Ohad Elhelo, thanks so much for doing this.
Hey, thanks, Nick. It was great.
This has been The Most Interesting Thing in AI. I'm Nicholas Thompson. If you've enjoyed what you've heard, please rate and review this on the podcast platform of your choice. Also, please make sure to hit the follow button so you can be alerted of future episodes. And leave us a rating and a review. It helps others find the show. Next week, I'll be joined by Will Ahmed, CEO of Whoop, to talk about the company's popular wearable fitness tracker and how it's using AI to help athletes up their game.